All right, this is a conservation of energy. So we're going to do part D here. This is a conservation of energy argument, right? So what they're saying is that this thing here is moving. Again, it's going to be the speed that you figure out here, right? So you figured out a speed here, and it was mass of the ball, velocity of the ball, right? That's this guy, okay? Equals mass of the ball plus the mass of the spike times the velocity of the ball and the spike, right? Okay. That's going to lead to this system here. Of course, it's moving with whatever that speed is, and that speed is between 4 and 5 meters per second. Okay, so we're going to set up a conservation of energy argument. We are going to say that 1/2 mv squared, so 1/2 mass of the ball plus the mass of the spike times the velocity of the ball and the spike squared, right? That's the kinetic energy that the whole system has. You're going to say that equals force times distance, right? So that we're trying to find the friction force. They're telling us that this is our distance, right? Okay. So now you've got this. Mass of the ball is 3.5. The spike is 0.8, right? Okay. The VBS, baby. That's what you gotta solve that, right? Get that and then set that up. I got when I did it, I got a slightly different number from what they got. So I've got a question on that. I think that they would give me credit for that. But I just don't know. All right, and then let's look at part E while we're at it, because E is not too bad, right? The machine that's used to raise the ball has a power of 18 watts. Calculate how long it takes for the machine to raise the ball through a height of 1.6 meters, right? So power is going to be work divided by time, right? Our work in this case is just the mgh to lift just the ball, right? And then that's the time, right? So you can just plug this in. Power is mgh divided by t. The power is going to be the 18 watts, right? M is going to be the mass of just the ball, right? G is 9.81. The height is 1.6, right? You know everything but the time, so figure out the time. It's between 3 and 4 seconds.